Here we are going to see the construction and working of alternator. Alternator is also known as AC generators or synchronous generators. We know that synchronous generators and synchronous motors are coming under the family of synchronous machines. Here let us discuss about synchronous generators or AC generators or alternators. Okay. Already we discussed about DC generators. Okay. We know that for the production of electrical power in rotating machines, there must be three requirements or three things are essential there. There must be a field system and there must be an armature winding system. If the relative motion between these field windings and armature occurs, then we will get electrical power. Okay. And for DC generators, we kept field system as stationary and armature system as the rotating part. Here in AC generators, it can be of two types, or we can arrange the rotating and stationary parts in two ways. That is, either we can keep the field as rotating and armature as stationary, or field as stationary or armature as the rotating part. Whatever it is, we will get AC current. But generally, we will prefer field system as a rotating part and armature can be taken as stationary part in alternators. Why? Because we know that in field system, the weight and size of the field system is very less. So we can reduce the mechanical losses and the machine can easily balance. Okay, that is one of the reason for using this, and we can easily insulate the machine if we are using armature winding as the stationary part, and the number of sliding contacts can also reduce. Okay, and we know that the alternator is a high current, high voltage machine. So we can easily take current from the fixed terminals. So due to these advantages, we can use armature winding as the stationary part and field winding as the rotating part in alternators. Either method we can adopt, but generally we can adopt this method. Okay. Then the basic working principle is of AC generator is similar as that of a DC generator. That is nothing but law of electromagnetic induction or Faraday's law of electromagnetic induction is the basic working principle. Okay. And before going to see the working principle, we can discuss about its construction. Okay. We know that constructionally there must be a stator section and a rotor section. And here the stator section including these things. That is stator frame. That is the outermost body of the alternator. The main function of this stator frame is to give or to provide mechanical support for the entire components for required for the alternator. So they are made up with very rigid material. Normally they are made up with cast iron or cast steel, like strong materials. Okay. The next part is stator core. Okay. This is the stator core, and stator core is made up with magnetic iron or steel alloys. Okay. And this steel alloys or magnetic iron which is insulated, which is laminated from each other in order to reduce the eddy current, and also they are laminated from each other. Okay, so it is very necessary to reduce the eddy current losses. So laminations are provided in stator cores, and stator core contains stator slots. The function of the stator slots are to carry the armature windings, stator armature windings. So we can provide the armature windings on the slots of stator cores. Okay, the stator winding is made up of copper material. Okay, these are the stationary part of an alternator. Okay, now let us see the rotating parts for an alternator. The right side you can see that first a shaft. The innermost portion of the rotating part is shaft, that is made up of steel like strong material. Okay, and these two rings that will represent slip rings. Slip rings are made up of golden or silver copper materials, and slip rings are connected along with two brushes. Brushes are made up with carbon or graphite materials, and the function of this slip ring and the brushes, that is they can provide DC excitation. They can give DC excitations to the rotating parts, to the rotating magnetic field. Okay, the field windings, to the field windings. Normal case, the DC excitation can be given from another generator. Normally we can use DC shunt generator or flat or over compound generators, because from the no load to full load, such type of generators can provide a constant voltage. We know that for DC shunt generators that it has a dropping characteristics, but whatever it is, we can say that it can provide almost a constant voltage from its no load to full load condition. So the DC excitation is given to the field windings through these brushes and the slip rings. Okay, the next important part, that is rotor with magnetic field. This portion is the rotating rotor, and this will indicate the magnetic field windings. Based on the construction of magnetic based on the construction of a rotor, the alternator can be of two types, or two types of rotor constructions can be there in alternators. They are, first one is salient pole type rotor or projecting pole type rotor, and the second one is smooth cylindrical type or non salient pole type. Okay, in this figure you can see the first figure will indicate salient pole type or projecting pole type. You can see that the end portion of the rotor which is projecting outside. Here you can see a 4-pole machine, and the end regions are projecting outwards. They are mainly used for low or medium speed applications because they have a large diameter and short axial length. Due to this short axial length and large diameter, they can only use for low and medium speed applications. Mainly they are used for hydroelectric power plants because we need high heads there, but the speed of rotation of turbine may be very less. If the number of poles are very high, then the speed will be very less. Or such regions we can use generating stations, we can use this salient pole or projecting pole type rotors in alternators. Okay, so in salient pole type it is very important that in salient pole type machines they are having large diameter and short axial length, so they are used for low and medium speed applications. For cylindrical type or smooth cylindrical type or non-salient pole type, we can see in second figure, you can see that it's they are having smaller diameter and large axial lengths. Due to these constructional features, they are used for high speed applications. Okay, high speed applications means that can be used for atomic power plant, nuclear power plants, or thermal power plants. And one more difference you can see here in cylindrical type, the air gap is very large, so flex may be reduced. But it is in the case of non-cylindrical type, here we can see a uniform air gap. So reduced reluctance can reduce, so can provide more flex, and thereby we will get more currents. These non-cylindrical types machines are also known as turbo alternators. They are running with maximum speed, high speed machines. If we are using a two pole machine, then they will rotate with 300 rpm. If we are using four pole machine, then they will rotate with 1800 rpm. So non-silent pole type machines are high speed machines. Silent pole types are low or medium speed machines due to their construction. And in this figure, you can see salient pole type rotors. Okay. So these are the major construction features of alternators. There must be a stator part and a rotor part. Stator parts includes stator frame, stator core, and stator armature windings. Rotor section includes shaft, brushes with slip rings, and rotors with field windings. Okay. Now let us see the working principle. That is nothing but Faraday's law of electromagnetic induction. For this, first we will give a DC excitation to the field windings through a brush and a slip rings. Okay, through a pair of brushes. DC excitation can be given to this rotor field windings from a DC shunt generators or flat or over compound generators, because already we discussed that because they can provide a constant voltage from its no load to full load. Whenever the field windings get excited, and we know that the rotor is rotating with the help of a prime mover. For hydroelectric power plants, that can be a turbine, and that turbine is mechanically coupled to the shaft of the alternator. So due to the rotation of the turbine, the rotor will starts rotating. And if we are giving the excitation to the field windings, then what will happen? The field windings get excited and flux will produce in that field windings. And due to this rotating motion, the produced flux will also rotate along with this rotor. And due to this rotating motion of the magnetic field windings will cuts the armature windings. In each and every time the rotating motion of the field windings will cut the armature field windings, and since they are closed, some current will induce in that conductor according to Faraday's law. Okay, so the relative motion between this rotating magnetic field and the stationary armature windings will provide or will leads to the generation of current in the stator armature field windings. Okay, and we can collect the induced or generated alternating current from the armature winding, from the stationary armature winding. And one important point is that the stator of the alternator is always star connected. Why? Because some advantages are there. We know that voltage per phase is very less in star connection. Voltage per phase VPH is equal to 1 by root 3 times line voltage. So we will get a reduced voltage in phase in star connection. So can reduce the insulation requirements, and also the number of turns can also reduce, and thereby we can save copper. For copper savings, we can construct the stator of the alternator as star connected. Okay, and also we can provide easy protection since they facilitates a neutral connection. The third, harmonics effects can also eliminate, and we know that in star connections no circulating currents are there, so heating losses can also reduce if we are connecting the armature windings in star. So we will get a safe operation. Okay, that is the working principle of alternator. Okay, so whenever the field get excited due to the rotating motion of this rotor, they will the magnetic field will be get excited, and due to this excitation they will induce some flux, and due to the rotating motion of this rotor the field will also rotates, and in each and every rotation time the flux or the magnetic lines of force will cut by this armature windings. Since they are closed, some current will induce in that armature winding. The relative motion between this armature winding and the field winding will provide currents in the armature winding, and you can collect the current from the stator or the stator armature windings. You will get a three-phase output. This is the major working principle of an alternator, and these are the basic requirements for the construction of alternator. Okay, thank you.